Welcome to the Huberman Lab podcast, where we discuss science and science-based tools for everyday life. I'm Andrew Huberman, and I'm a professor of neurobiology and ophthalmology at Stanford School of Medicine. My guest today is Dr. Melissa Alardo, professor of biomedical informatics at the University of Utah. Dr. Alardo is a world-renowned expert in human genetics and epigenetics. She conducts pioneering studies on how our behavior and the environment can modify our gene expression. Today marks the first time on the Huberman Lab podcast that we really explore human genetics, epigenetics, and how behavior shapes gene expression across generations. We talk about the inheritance of physical traits like eye color, and we dive deep into fascinating mechanisms such as the mammalian dive reflex, a physiological reaction to breath holding in cold water that, as Dr. Alardo explains, can dramatically alter the physiology of your spleen to allow significant increases in red blood cell count and oxygen availability to your brain and body. And by the way, the mammalian dive reflex can be activated outside of free diving, and you can even do it at home. We also explore how mate preference and selection in humans relates to the immune system. That is, if you were given a choice of many different mates, as most people are, the mate you would select is the mate who has the immune system composition that is most different from yours. And you would know that on the basis of their smell and how attractive their smell is to you compared to the smell of other people. We also talk about how differences in external traits signal important variations in organ function, hormone levels, and even brain physiology. Toward the end of our conversation, we discuss the current state and ethical considerations of gene editing in humans, something that's apt to be an increasingly important topic in the years to come because gene editing in humans is now possible and is happening. As you'll soon learn, Dr. Alardo does incredible real-world experiments that reveal the remarkable interplay between genes and behavior, and she's an absolutely phenomenal teacher who makes complex genetic concepts accessible and practical. The conversation is sure to change the way that you think about mate selection, your parents, their parents, and what you can do to optimize your physiology and health through behavioral practices that influence gene expression. Before we begin, I'd like to emphasize that this podcast is separate from my teaching and research roles at Stanford. It is, however, part of my desire and effort to bring zero-cost-to-consumer information about science and science-related tools to the general public. In keeping with that theme, this episode does include sponsors. And now for my discussion with Dr. Melissa Alardo. Dr. Melissa Alardo, welcome.
Thank you.
Nature versus nurture, super big question that we all wonder about, how much of our capabilities and potential and just general themes of life, everything from how we look to what we're capable of doing or not doing in the moment, or where we might be able to improve or not improve. We hear some of it's nature, some of it's nurture. So if we take a step back and we just ask a big question about human genetics, how much of our DNA is modifiable by our environment and what we do, what we choose to do in particular, because that's most of what we're going to emphasize today.
I think that's something we're still understanding at this point. I think every day we're getting more and more information about the ways that we can actually modify gene expression and these things that we thought were totally predetermined in the past. And so, I think we're still learning with epigenetics and all of these new fields just how much we can actually change things. There are, of course, things that are kind of written in our genes, but I think we're learning that there's a lot more that we can change.
Most of us at some point in high school learned Mendelian genetics, right? Mendel, the monk, and his peas in his garden. Most people probably don't remember the details of that, but we also learn about eye color. It's commonplace for people to understand that if both your parents have dark eyes, with very rare exception, it's unlikely that you're going to get light eyes as a child, but it's possible. But if you have one light-eyed parent and one dark-eyed parent, then you start to enter the probability game. And then at some point, your parents dictate a lot of your appearance, your phenotype, and yet that there are aspects of our parents that are not seen in us at all, and vice versa. And so I think for most people, when we think about genes, we think about heritability. But your work focuses a lot on the aspects of genetic expression that are subject to change based on what people choose to do or are forced to do in order to survive, something we call selection. So could you tell us about selection in terms of how quickly a given behavior, for example, can change our gene expression? I'm not aware of any way to change one's eye color without putting in like a colored contact lens. Now there's some esoteric things showing up online about people using these bizarre treatments to change their eye color. But for the most part, people accept that you're not going to change your eye color by behaving differently. But what are some examples where we can change our gene expression quickly, or relatively quickly, by doing something differently?
Yeah, just going back to eye color, because this is just one of my favorite genetics facts. So everyone with blue eyes descends from the same person. So at one point in human history, one person had a change in their eye color. And it's just like amazing to imagine this person who had blue eyes for the first time. And then through many generations, probably because that was a very attractive and interesting feature in that individual, that spread throughout human populations as we know them. So I always just find that to be fun about blue eyes.
So there was a blue-eyed F1, as we say.
That's right.
The first. Let's stay on eye color for a moment, because before we get into how genes can be modified by behavior, I've been told that the green eye phenotype is one of the more rare eye colors. Is that true?
I think that's right. Yeah, I think it's the most rare.
Okay, so and can we assume that there was an original F1 brown-eyed person that gave rise to the entire lineage of brown eyes subsequently?
Yeah, I think in the history of humans as a species, I think that was our original eye color. And so then, having these other eye colors arise in the population created these events. I think green eyes, if I'm not mistaken, there were multiple people, that comes from different genes from different individuals in the history of humans. But yeah, blue eyes is just this one individual.
I realize I'm slightly remiss on the statement about eye color not being subject to behavior. We know that as you get more sunlight exposure, in particular ultraviolet light exposure, that eyes will darken.
Is that right?
Regardless of where they start.
Interesting.
Yeah. So like a blue-eyed baby will have much bluer eyes at birth than it will at age 15, at age 80, for instance.
Yeah.
And we believe that's due to changes in pigmentation because of UV exposure.
That's really interesting.
I'd like to take a quick break and thank our sponsor, Juve. Juve makes medical-grade red light therapy devices. Now, if there's one thing that I have consistently emphasized on this podcast, it is the incredible impact that light can have on our biology. Now, in addition to sunlight, red light and near-infrared light sources have been shown to have positive effects on improving numerous aspects of cellular and organ health. Way to support us. In addition, please follow the podcast by clicking the follow button on both Spotify and Apple. And on both Spotify and Apple, you can leave us up to a 5-star review. And you can now leave us comments at both Spotify and Apple. Please also check out the sponsors mentioned at the beginning and throughout today's episode. That's the best way to support this podcast. If you have questions for me or comments about the podcast, or guests or topics that you'd like me to consider for the Huberman Lab podcast, please put those in the comments section on YouTube. I do read all the comments. For those of you that haven't heard, I have a new book coming out. It's my very first book. It's entitled Protocols, an Operating Manual for the Human Body. This is a book that I've been working on for more than 5 years, and that's based on more than 30 years of research and experience. And it covers protocols for everything from sleep to exercise to stress control, protocols related to focus and motivation. And of course, I provide the scientific substantiation for the protocols that are included. The book is now available by pre-sale at protocolsbook.com. There you can find links to various vendors. You can pick the one that you like best. Again, the book is called Protocols, an Operating Manual for the Human Body. And if you're not already following me on social media, I am Huberman Lab on all social media platforms. So that's Instagram, X, Threads, Facebook, and LinkedIn. And on all those platforms, I discuss science and science-related tools, some of which overlaps with the content of the Huberman Lab podcast, but much of which is distinct from the information on the Huberman Lab podcast. Again, it's Huberman Lab on all social media platforms. And if you haven't already subscribed to our Neural Network newsletter, the Neural Network newsletter is a zero-cost monthly newsletter that includes podcast summaries as well as what we call protocols in the form of 1 to 3 page PDFs that cover everything from how to optimize your sleep, how to optimize dopamine, deliberate cold exposure. We have a foundational fitness protocol that covers cardiovascular training and resistance training. All of that is available completely zero cost. You simply go to hubermanlab.com, go to the menu tab in the top right corner, scroll down to newsletter, and enter your email. And I should emphasize that we do not share your email with anybody. Thank you once again for joining me for today's discussion with Dr. Melissa Alardo. And last, but certainly not least, thank you for your interest in science.